there. First of all, C is a pin. By nature of the pin, although a couple of people didn't do that because they end up with too many unknowns, so they have to eliminate one. They eliminated CY or CX. That's a no-no. This is a standard pin. So you have CX and CY. By the rule of the static, you cannot have more than one more unknown, not two. One more unknown, because you cannot have more than 3 unknown in your system because you only have 3 equations, yes or no. However, I have mentioned it many, many times. This is all about two-force member. And as you see, I call it rod BD. You can call it cable BD. I don't know the way the picture is. Sometimes we put a rod there. Sometimes we put a cable there. As you see, it is a cable or it's a rod. But obviously, when you push down the blue part, that cable or that rod is going to be in extension, yes or no? So it's going to be in tension. Now, in tension means this, guys. The tension, when I'm looking at this point, first of all, this point is not here. Some people make that mistake. That point is a little bit above about 7.5 inches above the point. And then all I have to do, put here one force, which going in that direction. In that direction means the rod BD is under tension. You see, nobody saying that. You should be immediately understood that. This idea of the tension and compression was explained to you in a static when you were doing this cross member. Many people have a little difficulty understanding there, but now in ME 218, it's all about normal forces and all about the shear forces. Everybody understand what I'm saying? That therefore, you have to be very careful of what you are doing there. This member, we cannot solve it, but this is a cable or is a rod under the tension. That means this, guys. That means we are having a rod sitting there, or the cable or whatever, and that cable obviously is under tension. That is the load in that cable. Is that correct or not? The question is how much load. You cannot put here dx, dy, bx, dy, but because this is a two-force member, or it is in cable in this case, or a rod, even if it is a rod. So you can put here F sort of BD, F, BD. They are all equal in magnitude. Therefore, I have here to put FBD, and the slope of that is 4 run, and according to the picture is given there, 20 inches run, 15 inches rise, which makes it 4 and 3 for the ratio of 3, 4, 5. Is that understood? Which makes it much simpler. Now, we have to solve. This is the static part of it. We have to solve for CX, CY, and FBD. FBD is the amount of force you need for member BD. Is that correct? Which is the only member we can right now design it. No other member can be touched yet there. Now, not yet, because we don't know yet about the bending. This is the idea that still the students do not understand. When we come to this now to a rod or a cable which has a cross section like that, notice there could be 3 rods. This was explained in first lecture. This, if this is point A or AA or B, we don't call this anymore Fx or Fy or this and that. We call this one normal force. Why normal force? Because it is perpendicular to the cross section. So each section or each part of a material goes through a normal force or a shear force or a bending moment. We call it bending moment. We are not having torsion yet. We will explain that in chapter 3. Is that understood? So that's the idea. That was what it was presented in all your homework. Because every homework, the first 2, 3 homework, you were supposed to calculate normal force, shear force, and bending moment. So why so many difficulty here? I don't know. Nevertheless, that's the static problem. So first, I want to calculate the force in this member. In order to calculate force in that member, that is FBD. Is that correct or not? That's as simple as that. I explained that extra because I don't want you to make any mistake for your future homework or this coming quiz or next week homework, etc., etc. Anyhow, sigma m at C equal to 0. So the dimensions are given. This is 12 inches. This is 20 inches. And this height is 7.5 inches, all given to you. So you write that one. So you have 1,800. Take a moment about point C. That's the point C. this is point A, and that is point B according to the quiz it was given to you. 1800 times 32, and it's going this way, therefore it is counterclockwise, therefore it's a plus. Then Cx and Cy do not have any moment about point C, but FBD has the moment about point C. Many difficulty there. If you don't know how to take the moment, of course, this class becomes much more difficult. This force has two components, horizontal component and both of them have moment about point C. Everybody see it. One is above it, one is to the left of it. Is that correct or not? This one, how much is that one? You don't have to rewrite it that much. You have to do it in your head. That is not FBD. That is 3/5 of FBD. I have explained that. There are still a student in this class to write cosine of 4/5, cosine of 3/5. Means their math has to be totally revised. Is that understood? Yes? Okay, one more time. For those who do that sort of thing, this is 4, this is 3, this is 5. Yes? Usually when you see something like that and you want to calculate that theta, you say tangent of theta equal to 3/4. Then you calculate theta. Okay, so theta becomes 37 degrees or whatever. Is that correct or not? Then what do you need? You need cosine. Yes or no? Cosine theta. But cosine theta, by definition of cosine, what is cosine? Is this length divided by that length. Yes or no? So cosine of that angle automatically, no matter what you do, it is going to be 4/5. And sine of that angle, sine of theta, still people misunderstand that. Sine of theta obviously is this height over this. If this becomes a circle, you have seen it in calculus, in algebra. Yes, this is actually the definition of sine and cosine. Yes or no? So it is 3/5. Or anyhow, saying that one more time doesn't hurt. So therefore, what do I have here? What's this length? The vertical component. It is 3/5 of f. Is that correct or not? Yes. So therefore, this is 3/5 of f BD. I'm sorry, because that's BD. But that is the force multiplied by distance. That this is going vertically up like that. So I need this distance times 20 inches. So therefore, that's the moment, and it's going clockwise. Therefore, it is negative. The same thing with the horizontal one. The horizontal, this force is 4/5 of FBD. That's the horizontal. But then it has this distance there, which is 7.5 inches, and it is negative equal to 0. I cannot help you there because this is all about static. I'm sure that everybody knows that part of it. Of course, many people got it correctly. I'm not saying that, but everybody should get it correctly. F ends up to be equal to 3,200 pounds. So FBD, I'm sorry. So this is the static part. Of course, since there was a question about Cx and Cy, you need to calculate Cx and Cy by using all the x component and all the y component, which is very simple. Everybody can do it. However, Cx ends up to be, actually Cx become negative. Look, this is going to the right. This is going to the right. Two of them cannot go to the right. Everybody see that? So Cx become negative. So write it down. Sigma fx. Let's finish it, actually. Sigma f equal to 0 is Cx plus 4/5 of 3,200 equal to 0. So Cx become equal to minus 2,560 pounds. Similarly, sigma fy equal to 0. So you have minus 1,800 here. And then here you have plus 3/5 of 3,200 plus Cy equal to 0. And Cy become minus 120. Both of them, Cx and Cy, are in the wrong direction, but we just always put them in the positive format. Yes, sir. Okay, that was the static of this problem. The rest now is going back to the idea that what we had there. I asked you to calculate at a distance of 12 inches from C. I asked you in this member, which we cannot touch it for time being as far as the stress is concerned, etc. I asked you only to calculate internal forces and moment. I especially mentioned the moment in order for you not to miss the moment there, but some people did. Is that understood? Because this is what's going to happen. Now, You can consider the free body diagram of the left, or you can consider the free body diagram of the right. In order to lead you in the right direction, I gave you this distance. That means choose this part, which is, it is easier. Yes or no? Correct? So by saying that that is 12 inch, I'm telling you guys, take the right-hand side, but some of you took the left-hand side, which is okay. There's nothing wrong with that. Everybody, I mean, you have to do a little bit more work, especially by taking moment become much more difficult. Yes or no? However, taking the right-hand side, free body diagram of the right-hand side, remember what we end up with. This was 2,000. Now, these are external forces. 2,560 pounds going to the left. And also we had, these are external. This has nothing to do with it because this was a pin. These are forces applied on the pin, and this is 100 pin. This is the result of that operation, yes? Now I'm asking you to calculate the internal forces. The internal forces, many people call it AX, AY, MA, I don't know. That's a no-no. We already define our forces. The forces should be in the form of normal force, shear force, or bending moment. Remember that in the handout that I gave you, I said, look at this in the 2D problem. Look at the first handout. There is a picture there. And that's what you were doing in all your first few homework. Yes or no? Calculating that. Now, what should I have here? Of course, this is so simple that you don't have to use equilibrium or anything. So I have to have an N here. Yes or no? That's my normal force. Normal to the cross section. N equal to how much? N equal to? It's so simple, you don't have even to do it by inspection. You don't need any. The left-hand side, you have to use, again, equilibrium. Here, it's so simple. Of course, N become equal to 2,565. But is it in tension or compression? It is in compression mode. It's obviously there. Then we are looking for a force in the section. The force in the section causes the shear stresses. Is there a shear there? Of course it is, because if this is 120, this is outside, external. Look where I'm putting this. This one is internal. In other words, if this is a body like that, I want to show you a little bit bigger. These are external. You can put it up and down. Everybody under, but this one, it goes right through the centroid. This is N, which become uniform stress. Everybody understand that. And then there is a shear force going like that. We talk about tau equal to force over the area. Yes or no? Correct? I just want you to see what you are doing, because the thing that they are doing, the way you express your pictures and your ideas are a little bit. So there is a shear force of how much? 100? It's going up because we have not talked about the sign of that yet. It is going upward in that section. However, a couple of people or several people left it at that, but this is not in equilibrium. From a static, you should know that. Because look what happened here. These two are not a couple. These two are canceling each other, yes. But this two is a couple right now, yes or no? So this item is going to rotate. So it is not in equilibrium. I have to put a moment in the section to balance that. Everybody understands? And that moment is the question. You can put it positive. You can put it negative, either way. That I leave it up to you. So I know what the answer is. But look, this is going that way. The answer should be going opposite because the sum must be equal to 0. But we generally put it in positive direction first. So we say this is M in that section, and we calculate the M. Of course, the M ends up, again, you can calculate that. You will see that the M ends up to be equal to, you write sum of the M with respect to this point equal to 0. Then, so let's do it here. This is the static part. I don't have to do it. It's obvious to many of you, but let me do it. Sum of the moment at section AA equal to 0. This doesn't have a moment. This doesn't have a moment. This moment is already sitting there because I saw many mistakes. This is already a positive couple, yes or no? So plus M. And then we come here. This doesn't have any moment. This one has a negative moment because this goes 120 times, how much was it? How many inches was that? 12? Yes? Okay, it's 120 times 12, and it's going clockwise, therefore is negative, equal to 0. So if you plot it like that, look what happened. At least 10 people try to calculate M without showing this. The sign of what you are calculating depends on your free body There you can put it this direction, you can put it other direction. Everybody, like any other forces, you change the direction of the force, the number changes. It become plus, become minus, minus, become plus. Is that correct or not? Yep. So you have to commit first, then write it like that, or do it any other way you want to. In that direction, m become equal to 1,440 pound-inch, because that's what it is. So 1,440 pound-inch of moment, which is counterclockwise. Of course, if you go to the other side, you have to put equal and opposite. Those of you who came out with this result should be equal and opposite. This is the nature of a static, yes or no? So therefore, on the other side, in other words, on the other side, if you are coming from the other side, this should go like that, this should go like that, and this should go like that. That's the answer for that. Yes?
I'm just curious for the answers. Should we be sticking that information next to it as well, or is it implied by the problem?
Excuse me?
Like we have compression and then F arrow and then counterclockwise. Do you want that, or is it totally showing the problem?
No, you have to draw it, because some people, you may draw it the other way. You have to draw AM.
Right, no, I mean like when you wrote the answers.
Yes.
You have compression, the up arrow, and the counterclockwise.
Yeah.
Wouldn't that have written next to it as well?
Yeah, that's good. No, you don't have to write that one if that one. No, as long as you you understood what I just said. You know, just follow the. You must commit yourself to an M. Then the number is according to that one, because as I said, you can put it either way. However, after this is not required, so you just don't have to put it there because it's already there. That's what you're saying. Okay. All right. Now, let's go more. In this speed, we cannot go anywhere. So now we have solved all the static problem. Now, what is the question about the strength of material? Now, it's not about this rod, because this rod cannot solve it, because we haven't talked about bending, etc., etc. It's all about what was it? I forgot. FBD, yes or no? Okay, that rod or that cable or that rod or whatever is under, look what it is. It's as simple as that one. This rod is under the force and the pin is under the shear. As simple as that. How else can you go wrong? So if you end up with the wrong FBD, at least this part of it should have been correct. I gave you credit. But you have to follow the rule. The rule is, first of all, look at the end. The end is being reinforced, so you do not need to subtract the whole area, yes or no? And of course, it is under tension. Therefore, you write sigma. Sigma was given. Sigma allowable was given for this rod or that cable was equal to 12,000 psi or pound per inch square. Now, guys, I saw many mistakes in your unit. Now, engineering is all about the unit. The first thing you tell to an engineer, you say 50. I said 50 what? So it doesn't mean anything. 50 Newton, 50 pound, 50 stress, which is pound, PSI, KSI, Pascal, kilopascal, etc., etc. Many people even do not pay attention to the 1,000 or 10,000 here, especially in the other class, because I gave them a metric system, all sort of trouble there. Anyhow, yours was a little bit simpler. So sigma allowable was 12,000 pound per inch square or PSI equal to the load. The load is 3,200 pound. We already got it divided by area. The area is pi over 4 diameter of the rod square. So that's it. So that's area. I did not ask for the area. As you see it in the question, I asked for the diameter of that bar. Is that correct? Or cable, the way it looks like. Anyhow, you calculate dr. dr become equal to 0.583 inches. This is another point. Next time I'll subtract point. When you do calculation in engineering, you need to go to minimum of 3 digits. Please write it down. Minimum of 3 digits. You want to go for every answer should have at least. Some people leave it at 0.58. Everybody address. Or some people even went to 1 digit. That's no good. Is that understood? All right. And then the next question was, what are these pins? Yeah, because now look, this is the force. This pin is under that force, but it is in double. Yes or no? Double pin. It's like this. So therefore, tau, this time tau allowable was given equal to 7,500, again the same unit, pound per inch square, equal to force, which is 3,200 pound, divided by 2, I'm sorry, pound divided by 2, because it is in double shear format, pi over 4, diameter of the pin, it's B or D. This analysis is for pin, you can write it like that, B/D. This is for the rod. So you just specify what you are doing, so that makes reading a little bit simpler. Nevertheless, this one, D of the pin, become equal to 0.521 inches. And finally, what is the size of the pin at C? Yes, so there is a pin here too. Is that correct or not? We cannot, again, touch the rod, but we can do that. But for C, I explained that in class to you. For C, you have two forces like that. You have to find a resultant. That was explained. Some people took Cx, some people took Cy. That none of them is correct. C is equal to Cx squared plus Cy squared. So C become equal to actually a little change because not minus goes away. So it's 2,560 square plus 120 square. So you calculate that one, become 2,563 pound, and you use the same formula again. Tau allowable, 7,500 equal to, this time is single shear, and the force is 2,563 pound divided by pi over 4 diameter of C square. This time diameter of C ends up to be 0.66 inch. Actually, you see this part was repeated. There was nothing there. So please, next time, pay attention to what you are doing. Hopefully, you do a better job now. Now, as far as your homework goes, there must be many questions that you may have having looking at the homework. So I'm going to explain now all of that. Now, I want you to be careful here. I want you to understand the technique. You are, some of you are still under this illusion that you are looking at the formula and everything will come to you. No, no. Look, I'm going to do 4 or 5 problems today. Every one of them are different, and every one of them has to be analyzed by you. When you come to the quizzes and your homework, that is why the solution manual become useless. Everybody understand that, because solution manual will tell you what to do. By the way, the next bunch of homework, I'm suggesting you do not look at the solution manual at all, because their method is totally different, it's confusing, and they just suddenly put a formula there without you recognizing that. Please pay attention to what I'm saying, that make a note of that. That will help you 100% to do your homework. Everything that you want to do, you know about the homework, is going to be explained today. Okay, the 3 equations that we have is very simple, that you should recognize those equations. One, of course, sigma equal to P over A. We already talked about that. Those are the last week lecture. Tau equal to 4. These are, again, internal, not external. Remember, I changed them to N and V for just that purpose. Is that correct or not? Yes? That the book always do it that way in engineering book. But these are internal, not external. In other words, we are not talking about this and that and that. We are talking about what I just erased it here, what was inside of this body. Is that correct or not? Yep. Anyhow, and that is last week. Now, last Thursday lecture was this, epsilon. What was epsilon? Epsilon was the amount of deformation per unit of length, which we define it 2 ways. One way was delta over L, delta being total deformation, L being the length of the object. Obviously, epsilon become the amount of change per unit of length. You have here 10, you have here 100, 10 changes per 100 foot. So you have 1 per 100. Is that correct? You have to divide that to get how much you get for 1 foot. Is that understood? Yes? And then another definition we gave you, which is very important, these are normal strain, by the way. Sigma over modulus of elasticity. Where did it come from? This came from Hooke's law. You remember the curve that we plotted? Yes or no? Remember that slope of that curve? That's the modulus of elasticity. You have to get used to this idea. By the way, in the quizzes, I will give you this. You don't have to remember this. That's the whole idea there. That's what I'm saying, that don't forget about the formula. The formula will be given to you. And the last one that I end up putting these two together, calculating the delta. The delta was, of course, you don't remember it because you haven't done your homework. As soon as you do the first or second homework, I'm sure you are going to remember it. Is that delta equal to PL over EA? Now, the whole idea of this homework that you have to do and this handout that I gave you is all about this. So look at problem number 1. Okay, everybody, while I'm erasing the board, you should look at the problem, understand it, at least have some idea how to be being handled or what is your approach to it as soon as I mention that. And then I'm going to do it. So if you have some ideas which is wrong, then I'm going to correct it. If you are in the right track, so be it. So you are already there. There is a rod there. Everybody see that? Problem number 1 in your handout. I have a few extra ones if you need. Everybody needs this handout in front of you if you need one. Come on, guys. This is a no-no. Every time you come to the class, my friend, you bring your handout with you, okay? I'm not going to print this anymore, but this is unfortunate. And I'm lecturing, and you're not looking at this picture. I keep saying in the email, you need this material to understand that lecture, and still you are coming without that. That means you are not. Anybody? I have here extra one. Anyhow, I have it still from the past. Here, would you please pass it on that way? Anybody else? I'm sorry. Okay. One more left here. Do you want it? Anybody else? Okay. All right. I need one too. Okay. All right. Let's go to problem number 1. Look at problem number 1. We have to go a little bit fast, otherwise we will not be finishing this one. It is a 2-part. Because this is for 1. I asked you at the end of the class, I said we have to put a summation. This is an example of it. Yeah. Quite frankly, I asked you whether you did your homework or not. If I were you, all these problems should have been handled by you because there is not much into it except some of the detail we already talked about it. This is 2-part rod, and this rod could be different material. This could be different cross-section. Of course, there are different lengths. This is 600 millimeter long. This is 400 millimeter long. This is point A. This is point B. This is point C. There is a 40 kilonewton load here. This rigid part doesn't matter. We are just putting there in order to apply a load to it. And here it is 50 kilonewton load here and 50 kilonewton later, as if I am applying 100 kilonewton to the center of the rod. That's what is important. Yes? Okay. So therefore, all the load are, this member are axially loaded, we say. These the load are at the center of the rod, centroid of the cross section. Okay. Obviously, the question is, this rod is going to go through a change, yes or no? This rod is going to go through a change, but we have to find out whether they are under tension or they are under compression. As I asked you last night, don't look at this number. You have to go inside of it. So therefore, I want to calculate delta of rod AB. So if I want to calculate the delta of rod AB, obviously I need L, E, A, all given if you look at the handout. All I need is the P. This P is not this or that and that. That's the mistake that everybody makes. If I call this one P or call that one P, these are not the one. What are that P? I said it many times. That P is the internals. And if I ask you what's the load in that member AB and you say it is 100, obviously you are wrong. Everybody understand the load in the member is not 100. Yes? What's the load in that member? This is what we practiced last time. Remember, I gave you example 5 in the first handout. I show it to you. And we taught this, by the way, my lecture this week, Thursday, is all about that. You need to be good at this. Otherwise, you will not understand a word of it because it's all depend internal versus external. It becomes very complex because it becomes indeterminate problem, this and that. However, look at this. What is the force in this member? Can you see it or do you need a free body diagram or that? That is 40 in tension. In other words, this is, you don't need that, but I'm drawing that. This is external load going like that, 40 kilonewton. You make a cut here, cut 1, 1. That's the cut there. Yes. So in the body, now I must have a force going like that, 40 kilonewton. So therefore, the member is under 40 kilonewton of tension. Not the right-hand side, the left-hand side. We are doing the color one. That's what indicating, because this member is going to be. So you put here 40 kilonewton tension. Now, what happened here, we have to do the same thing, but we have to look either on the left-hand side or the right-hand side. Now, I'm going to look at the right-hand side because for more complex problem, I need that. So if I'm looking on the right-hand side, this is what I see. This is the entire length. This is B. That is C. I have cut it here. This is cut 2, 2. We did that last time. Is that correct or not? So when I make a cut 2, 2 here, I'm somewhere here. Is that correct or not? Somewhere between A to B. This was clear last time. So I have here 40 kilonewton. I'm sorry. And here I have 50 kilonewton. And here I have 50 kilonewton. What should I put here to make this in equilibrium? I don't know why. What is the fuss about this? This has been explained 2, 3 times, but anytime I give a quiz or a final, a few people or half a people get panicky again. What's the force in that member? Well, how much force should I put there to make this equal to 0? Is 40 going to the right, 100 going to the left, so I should put 60 going to the right. But 16 going to the right, what does it mean? Forget about now. Here, cover this. If I put this force here, is it under tension or under, I am pushing it or I'm pulling it? Pushing it. Everybody see that? This is not statically positive or static. Right now, if this was fixed, you are compressing this. Is that correct or not? Therefore, oh, sorry, I ruined my picture. So for the video. So that's for your sake anyhow. So first, is that understood? Yes? Correct? So this is right now internally, this is 60 kilonewton, not 100 kilonewton, 60 kilonewton, and it is in compression. That means member AB gets shorter, member BC gets longer. Anyhow, so now let's calculate. So you put this here now. You put this, instead of that, you just put here 60, I'm sorry, I should use color, just to be consistent. So internally, that's what I have here. And internally, again, my wrists are all crossed. So, okay, here, this one, 60 kilonewton, and it is in compression. Now, the delta is very simple. First of all, in order to calculate the delta, I need the area. What's the area? Look at that. What's the area? Is a circular rod, so it is pi times radius, which is 10 millimeter to the power of 2, so it becomes 314 millimeter square. But notice everything has to be in Newton and meter. So I have to convert that into meter. So that is equivalent to 314 times 10 to the power of minus 6 meter square. So I have to use minus 6, not minus 3, because it is millimeter to the power of 2. Yes? Many people only put 1,000 because you are not converting into meter to the meter, or meter to the millimeter. You are converting square of that. Is that correct? So it's 1,000 to the power of 2. When you go to the moment of inertia, you should use 10 to the power of 12. I have seen many, many mistakes in the quizzes, in the final, in that respect, because people do not pay attention to the unit. Is that understood? Yes? Meter, millimeter square. Anyhow. Now calculate delta. Now here we want delta. Delta is the amount of deformation of the rod AB. First of all, it is negative. Why is it negative? Because it is in compression format. And the force here is 60 kilonewton, or 60 times 10 to the power of 3 Newton. Yes or no? Correct? Everything should be Pascal. Pascal is Newton per meter square. So please be consistent in that one. Then PL. What is the length? The length is 600 millimeter or 0.600 meter. This is the first time how I'm going to use the unit there in order for you to do. After that, you don't need to put the unit there, but you should be consistent in your mind. You should carry it. Be careful. Is that correct or not? Then divided by E. What's the E for this still? This seems to be a still. It is equal to 29 G Pascal. Yes or no? Or 200. I'm sorry. 200 G Pascal. So G is 10 to the power of 9. That's right. So therefore, 200 times 10 to the power of 9 Pascal, which is Newton per meter squared. This is lots of writing, but you don't need to do that after. I just want to show you what's going to happen first time. Then after that, you just keep track of everything. Multiplied by what? Multiplied by area, which is 314 times 10 to the power of minus 6 meter to the power of 2. Now look what had happened. This meter to the power of 2, that meter of 2 drops out, yes or no? That Newton and that Newton drops out, so the delta will be in meter. If you want, you can multiply it by 10 to the power of 3 to get it in millimeter. But usually we leave it at that. So this ends up delta AB to be equal to minus 0.573 times 10 to the power of minus 3 meter. By the way, we never use in engineering application. Our answer is always in the form of 10 to the power of 3, 10 to the power of 6. I have mentioned that before. We follow that rule too. We never end up with 10 to the power of 4 or 5 or 7 and 8. It's always 3 or 6, minus 3 or minus 6. That's it. That's all engineering work. Anyhow, so you understand that. So it is AB getting shorter. However, BC going to get longer, the same format. Let's go a little bit faster. Okay, delta BC, this time the force is 40 times 10 to the power of 3. So this time I'm not using the unit, but I'm keeping track. And the length is 400 millimeter or 0.4 meter. E and A are the same, so I'm not going to put it there because I want to shortcut it to give you more ideas. This is the same E. If there were different number, we will put it there. Sometimes one is aluminum, one is steel. Everybody understand that. So but these are made of the same material with the same cross section, so I have to put the same number there. Is that understood? Yes? Read the question again. Is that understood? These are the same rod. The only thing actually is changing is the force and the length. Is that correct? E and A are the same. So use the same E and E there. So this time the change become equal to 0.255 times 10 to the power of 3 meter. Oh, I'm sorry, I didn't finish that one. Equal to this one become minus 0.573 millimeter. And this one become 0.255 millimeter. We usually express the delta in millimeter, the smallest unit that we can find. Is that understood? Yeah. Remember last time I mentioned to you that we express the epsilon in micro, which is 10 to the power of minus 6, correct? All right. So that's it. Now, next question. Read the question now. Next question is what? How much point C moves? See, how much point C moves something to do with delta 1 and delta AB and delta BC. Can you answer that question? Obvious. Everybody see the answer there right away. Yes? You see, this delta AB is getting shorter. Everybody understand. BC is getting longer. How much point C moves? First of all, is it moving to the right or moving to the left? What do you think? To the left, because this is larger than this one. How much to the left? Now let's calculate that one. Now, in the book, they use small delta. Don't use, this is not a small delta. A small delta is the deformation of the rod. Everybody understand that. Capital delta is displacement. Point C is going to displace because rod AB and rod BC are going to change. Everybody, look how the notation is very important. Is that understood? Yes? How much point C moves? Actually, if these two were equal, in magnitude, point C will not moving at all. Everybody see what I'm talking? It would stay the same. However, you just read it correctly. Displacement, please write it down. This is not deformation. This is deformation. This is deformation. That's the deformation. This is the displacement. Point C move because these two rods are getting shorter or longer. Of course, that's equal to minus 0.573 plus 0.255 or equal to the balance of that one. So balance of that one, that's no problem there. Everybody can calculate that one. And where did I put my note? Here somewhere? Nope. Okay, you can calculate that. So, the balance of that. Is that correct or not? Now, can you tell me how much point B moves? Or either that number, or that number. Which one, how much point B moves? A, notice A is fixed. Yes, A is not moving. How much B moves? B moves to the left minus 0.573. Everybody see that? What happened there? Yes? Everybody okay? Okay, next problem. Now, while I'm erasing the board, now look, there is one formula or two formula, 10,000 questions. Everyone is different from each other. Look at problem number 2. Come on, guys, read the question. Have some idea for yourself first. How much understanding you have from that problem will help you to set up your homework. And each problem has a different idea attached to it. Okay, problem number 2 in your handout. Okay, there is a rod there, yes? And the rod is under tension because you have a rod there like this. There is a hook there, and there is a P here, and that P is how much? P is given equal to, okay. I'm still looking for my first handout here. Put it somewhere, then I put it. Okay, how much load is there? I need to look. Yeah. Not my solution, I'm looking there. It's 60 kilonewton. Yes or no? What's the length of the rod? The length of the rod is not 400. The length of the rod is from point A to point B. There is a little plate there on top. Is that understood? I made it a little bit larger. Yes or no? Okay, can you calculate the delta? Yes, delta equal to PL over EA. The point A is going to go down. Yes or no? But the rod is under tension. Is that it or something else happened? Notice where that plate is sitting. The plate is sitting on a spring, which is a circular shape. Everybody, and there is a hollow at the middle. Yes? What do you think was going to happen to that spring? This is the machine part. Everybody understand it? Yes? What do you think happening to spring? Is it going to be under tension or is it going under compression? The spring is going to get shorter or is getting longer? Shorter is going to go down. Now, what happened here? You apply this force. This is not attached to wall or anything. There is a force there that this plate wants to go down. Yes or no? So therefore, this spring that's sitting here like a cylinder here, that spring is going to be pushed down. So let's say that the spring goes down ½ an inch and the rod goes down 1 inch. What's the total displacement of point E? Should I add it or should I subtract it? The spring is going down. Okay, if I push this one, see this one is sitting here on a solid base. You see, that's the whole thing. Everybody see what I'm having, right? When you push this one down, the spring will go down. Yes or no? This end going down. This rod also is going to stretch upward or downward? Downward. So I should add the two together. That is the part of a problem. After that, it's all calculus. Everybody that you do this, this is 90% of the problem. The other 10% is adding again delta equal to A. Everybody getting the idea there? Now, when you go to the solution manual, what are you looking for? You are not looking for the calculation. You are looking for the ideas. That idea has to come by you in every homework. Every homework has a set of new idea there. One more time. Forget about this rod. If I push this plate down, everybody understand that, yes? This is going to get a little bit shorter, yes? This is the delta of a spring. We talk about it, how to calculate delta of a spring. You already know that from physics. Is that correct or not? That means the rod with the plate will move a little bit down equal to delta of a spring, yes? But at the same time, when it comes here, the rod is already being stretched downward there. So I need the displacement of point A of this system is actually equal to delta of the rod AB plus delta of spring. Is that understood? Because both of them moving in the same direction. Notice the first example, they were against each other. I have to subtract. Here, both of them moving in the same downward motion, correct? Okay, now what is delta AB? Now it is very simple. Delta AB, actually I use the same data as for the other problem in order for you not to repeat the number. Delta AB is equal to what? It is the force. Force is 60 kilonewton. We already did that. Exactly the same problem. What's the length of it? You correctly identified the length of it to be equal to 800 millimeter, which is 0.8 meter. Up. Okay. Then divided by E. E is the same number. Is that correct? Or how much E did I give? Is it different or the same? E is 200 G Pascal. So actually I gave the same number. 200 times 10 to the power of 9 and plus multiplied by area, the same 20 millimeter rod, which is, I calculate that one just a minute ago. 314 times 10 to the power of minus 6, because this is the same as the previous rod. Is that correct or not? Then you put these two together to calculate your total. Somebody get a calculator until I find my solution here somewhere. I lost it. Oh, here it is. I'll put it down here so I'm good. So you calculate that delta. The delta become equal to 0.764 times 10 to the power of minus 3 meter, or equal to 0.764 millimeter. If there was no spring there, the rod would have been stretched that much, yes or no? However, the spring is going to move down as well. We talk about it. What is delta of a spring? Now, to calculate delta of a spring, you have to go back to physics. Everybody, what's the force in a spring? The force in the spring is equal to K stiffness factor multiplied by change in the length, which is the delta. Not the original length. Change in the length, which a change in the length is how much is going to be compressed or extended. That's the formula from physics classes. You already know that. So therefore, F is already given. The F that applied here is the same amount of force, which is 60 kilonewton. So therefore, 60 times 10 to the power of 3 newton equal to K. What's the K? The K is given 50 mega, yes or no? 50 times 10 to the power of 6. 50 times 10 to the power of 6 Newton. Let's put this one, unit again. Newton per meter, yes or no? And then delta, and delta will be in meter. So as you see, therefore, look what happened. That Newton and Newton drops out. It goes there. So delta will be in meter. So to calculate delta from this equation, delta become equal to 1.2 times 10 to the power of minus 3 meter, or equal to 1.2 millimeter. So of course, the final result is this point A goes down sum of the two. Is that correct? Yes? So delta, again, write it like that. These are deformation. This is not. This displacement, how much point A goes down, is delta of A is equal to 1.2 plus 0.764, or equal to 1.964 millimeter in downward motion. That's the thing. Look, totally different. Still, I'm using one formula, guys. Delta equal to PL over EA, yes? Now, look at problem number 3. Problem 3, you have to do that one. It's like problem number 1, but instead of 2 parts, it is 3 parts. You assume A is fixed because it says that find the displacement of D with respect to A. Somebody asked me at the end of class, so you are assuming A is fixed. You calculate the displacement D exactly like that. Let's go to problem number 4, because that's not a new idea. That is put there in order for you to practice that. Already practice 1. Practice 3 is your job. There are some other problems in your book too as well. Everybody see that? To get that idea established in your system. Now again, I'm erasing the board. You look at the problem number. I was hoping that over the weekend you do that, but apparently you are not that anxious to get this all started. So therefore, read it now. Read it and tell me what is happening in this problem. Every problem here has a different approach. That different approach is the question will be raised in your quizzes. Everybody getting the idea there? And you need to practice it through the homework. Come on.
Which question?
Problem number 4 now. Next page. One more thing, I'm asking you, please be quick, because we have to finish this course together. So don't just wait. After problem 3 is your homework, so we are doing problem number 4. It must be next page, which is page 2.1. I added that one. Okay? Yes? What's going to happen here? Come on, guys. We have to go fast. I'll give you a hint. That rod here, which is standing there vertically, that rod is rigid and is not going anywhere. Correct? And unless something happened there, so that rod I'm putting here. This is point E. This is point C. This is point A. It is a rigid bar, means it does not deform. It may go in the angle there and there, move forward, move backward, etc. And it's there. There is a load applied there. There is 6,000 pound or 6 kips load applied there. What do you think happened to this structure? This is all engineering work, guys. Engineering work means you are coming out with a new idea and you want to design it. Okay, nobody's done it before, but this, everybody has done it before. But now, if you go in the outside world, that's what you want to do, is that new car, design a new car with a new part that nobody has used it before. You have to design it. Is that correct or not? Yep. All right. So what's going to happen there? Is this rod is going to stay in this vertical position, or is going to move? Is it going to move forward, or is it going to move back now? Look at it. There are 2 cables there, yes or no? The cables are under tension or under compression, you think? Because if I'm getting this rod and pulling it this way, there is cable here. I already explained it to you. There are cables there. Those 2 cables are going to be stretched, yes or no? And there are 2 force members, correct? So you cannot go wide and put dx, dy, bx, by. Everybody understand? Those wide, the whole chapter 1 and 2 is about 2 force members. So therefore, this cable DC and cable BA are going to stretch, yes or no? Are they going to stretch equally? They are different length, different cross-section, different load. Everything is different. Even they could be different material as well, but they are the same. The only thing is common is the E. Is that correct or not? So the one is going to go further up, the other one going up. Which one do you think to go more? The bottom one, because it's longer. Depend on the load too, of course. You see, we don't know that, but because of the system, yes, you are right. The lower one will go a little bit longer, but don't assume that's the case, because if the load is less, then the length is large, they compensate each other. You understand what I'm saying there? However, I can tell you the load is more as well. So now here is the scenario. Back to your quiz or your homework, the previous homework. When you draw this free body diagram, there must be a force here, there must be a force here. Yeah, because those are 2 force members. You have to draw the forces in the direction of the member. And therefore, I have a force FCD. And here I have FAB. These are drawn in not statically, they are negative, but they are drawn, again, I explained that at the beginning of this lecture today. They are in the form of tension Of course, everybody understands because it's going away from the joint. Yes? One more time. I don't want to repeat that. The rod itself, which is too long, it is about 4 feet long. Everybody understand that the cable is under tension. These two must be equal and opposite. I cannot say that anymore, so I hope that is the case. Yes? So I have put these two under tension mode, and it is tension mode. Why? Because there is a rod here, and you are pulling that rod with it 6 kips or 6,000 pounds here. Yes or no? Can you find these two forces? This is the static part of it. So free body diagram of that object there, or that rod, vertical rod, is your static part. Correct? Can you solve it? Of course, it cannot be any simpler than that. Yep. I can tell you the answer, what it is, because this is 1 foot, and this is 2 feet. Yes or no? That's what is given. So I tell you, this is twice as much as that one, so this must be 4, that must be 1, because this ratio applied. Now, if you don't see it that way, you take sigma m at A equal to 0. Yes or no? Correct? So here you have FCD times 3 feet. You can leave it at 3 feet because we are using the same format. And then this is positive, minus 6 times 1 equal to 0, or FCD must be equal to 6 over 3 or equal to 2 kips. So I told you in advance. So this is 2 kips, and this is 4 kips. That's the static of the problem. Yes? You don't do the static, you cannot go any further with this problem. Yep. Okay, what happened there? Next, I want to see whether this rod, which was here, if the delta of this cable and delta of this cable is the same, this rod moves forward. Yes, sir. But you said it's not the same, but let's check it. Yes? Now I want to calculate delta of what? Delta of, delta of cable, look at your picture, cable AB. Cable AB has a length of 6 feet. It's very long. Is that correct or not? How much delta, how much is going to be stretched? That's the point, correct? Yes? So delta AB equal to what? Again, this is repeat. PL over EA. What P? This is AB. What P? Plus, first of all, 4,000. 4,000 pounds. Yes or no? Correct? Yes? The force in member AB is, we just calculated, statically is equal to 4, not 6. Yes? 4 and 2, this is the 6. Is that correct or not? Yeah. Anyhow, 4. What's the length? What's the length of cable? Look at your picture, not here, because I purposely give you the handout. What's the length of cable AB? Is 6 feet. Yes? Many people in the final and the quizzes multiply that by 6. Is that correct? No, everything should be in pound and inch, always inch, not foot. We never use foot, guys, for the stress. Stress is always pound per inch square or kips per inch square, which is KSI. Remember that. So everything has to be in inch. Is that understood? You don't go change these 2 feet into number. You just adjust it in your formula, again for the last time. Don't change by data. Data remain the same. Your formula changes. You add 12, divide by 12. Everybody understand it, okay? So not 6 feet. 6 times 12 inches. Yes or no? That's the length of that cable. Divided by E. E is how much? E is 7,400 KSI. Yes or no? Is that 17,000 KSI? Then I have to multiply by 10 to the power of 3 to match the pound, or I can keep and keep. Remember that will work too. Since I use here pound, I have to make this into the pound per inch square too. Is that understood? Yes? Okay, my friend, are you with me? All right. Multiplied by area. Area is given equal to 1 inch square. So that's what you calculate. Anyhow, delta of AB become equal to 1.5. Okay. Thank you. So here I had delta CD first. Okay, 0.0110 inches. Very small. Notice these deltas are very small. Sometimes you don't see it by eyes. Is that correct? The same way I have to calculate delta of CD, the top cable. Delta of CD, this time the force is 2. I used here kips in order to use the other option too. Here I use as kips, multiplied by length. Length is 4 feet, 4 times 12, divided by 17,400. Since this is kips, this is KSI, it matches. Is that correct? So you can use kips and kips, or pound. It's okay. Is that understood? Yes? So therefore, multiplied by the area of that wire is 1 times 1 inch square. So you calculate that one, this one becomes 0.00550. Exactly half of that. It just happened because this was a test. I just wanted to make the discussion easier. Yes or no? Actually, it's a little bit more. It's 0.055. By the way, another idea here, I mentioned it earlier, you want to carry everything to 3 digits. So if there is another point, you have to put it there. Now what happened after that? Come on, guys. Finish the problem for me. Because these are the type of question it might be asked from you in the final, in the quizzes, or in the engineering work. That's the whole idea. Now what happened here? This point A goes further here than this one. Yes? So let's plot it here. So this was the original location of all those points. This was point C. This is point A. The wires are there. These are now not in a scale. I show you that in order for the discussion purposes. This is not in a scale, but this A went to this point A prime, correct? And the distance was how much? 0.011. Yes, 0.011. 0.011 inches. Yes. And then this one went half of that. C went to C prime. And this is the location of the rod. You can do it any way you want to. That's the location of rod after this displacement. Yes or no? Because this wire go longer, so this goes longer. It becomes like that. Is that correct? All right. All right. Where is point E, though? Look what the question is. The question is, what is the displacement of this point F? Yes or no? I want to see what. I don't care. Right now, I have calculated how much A is going to be displaced, how much C is. But that's not the final answer. That's what I said. Read the question. The question is, what is the displacement of point F? Point F is here. So if I want to calculate how much F moves, I need first to calculate how much E moves. Where is the E? E is the ratio. Look, this was 1 foot. This was 2 feet. Now, this E has moved to here. You see that? This becomes a geometry problem that everybody should be able to do it. Is that understood? Yes? In the book, if you go, they calculate theta, but I do not do it that way. What I do is this for you guys. I divide that into, look at, first of all, this is 0.0055, which is exactly half of this, yes or no? Therefore, I divide that into a rectangular and a triangle. This length is 0.0055, and I need to calculate this one. This is a little geometry that everybody can do, correct? Hoping. Yes? All right, so distance EE prime is equal to 0.0055. What is this distance? Let's see. The total distance is 0.011. This is 0.0055. And this is 0.0055. Twice of that becomes that. Is that correct? Do I need this to add to that, or do I need this? This is less than this one. Yes? How much less? If this was at the middle, would that be half of this? Yes or no? But it is at 2/3 distance. So I need 2/3 of that. Yes? Did you get it? Plus, if this is x distance, let's call it x amount, because this happened to be the same as the other one. So let's put the other number. No, let's leave it at that. This is x amount. You see this one? This from here to here. Yes? So I need plus 2/3 of x. Agreed or not? Because this is 2/3 of this one. Because this is 2, this is 1. This is using the ratio. Yes? You figure it out at home. This is something you can do. This is high school, guys. This is nothing to do with you here. This is a little geometry using the ratio, yes? Notice if this is 0, this is 0.005. I said if it is at the middle, will be half of that. Yes? This is more than half. It's a little bit lower. Yes or no? It's 2/3 of that because the ratio is 2 and 1. Is that understood? Figure it out by yourself. So that is 2/3 of that amount, which is 0.0055. So the total become equal to the movement of that part. This is really geometry. It's not that difficult. Just you have to think about it correctly. So that become equal to 0.00916 or 7. Half of that, you have to calculate that. So this is what I have here. Is that understood? Yeah. Oh, is it in inch? Yes. Correct? Is this the final answer? No. No. Very good. Now, final answer is what? This is movement of E. I need movement of F. So delta of F obviously equal to that. Everybody see how the logic one step is dependent on the plus what? Because this is also a rod. From E to F is a rod. Is that rod is going to expand? Yes, so I need delta of that rod. Is that correct? Plus, I put it this way, you can calculate it yourself. Plus delta of EF. Delta of EF is PL. Look how many times I use PL over EA. PL over EA. What's the force in EF? The force of EF is 6. The length is 1 foot. The area given, the E is given, whatever is given, you use it that. I don't want to explain that because that's simple. Everybody said the logic is important here. Notice how many times I have to use logic to get this problem. And unfortunately, again, as I said it earlier, now you understand it better. People try to formulate everything, and there is no formulation because each problem is different from other problem, but all of them come under the same category of delta equal to PL over EA. So display. Anyhow, the delta of F after you put that, because this is the 6, you have all the number there. So therefore, it becomes 0.00917. You can check it at home. This becomes 0.00207 inches and inches for a total of 0.0112 inches. Okay, don't go away. We have another problem to talk about, which is very important, which is one of your homework. How much time do I have, or how much time do I don't?
30 seconds.
30 seconds? Okay, but let's at least discuss it. So I'm sorry, there is one homework related to problem number 5. Problem number 6 is very simple. Let's look at problem number 5. I give you the idea. Again, adding, multiplying does not make any changes. Everybody by now should be able to calculate delta. That's not the point. Is that understood? Look at problem number 5 and tell me what kind of displacement or deformation do you have there. As soon as you have this, the rest become very simple. The rest is just you have to watch out not to make any mistake in the unit, etc., etc. This time you have a rod here. Look at the rod. And the rod is very interesting problem, actually, this one. And okay, that's BCE. So this is BCE. This is 15 inches long, BC, and then to 25 inches rod. And then we put here at E, we put the load here. It's not shown in the picture in your, 10,000 or 10 kips or 10 kips or 10,000 load at point E and pulling it down, noticing B is not a pin. If B was a pin, like last week problem, this would have moved like that, yes or no? This is free, is better. They are attached to other link. The other links are going to move, yes or no? Because the other links are the two force members. So point B may be going up or down, that's the key. Point C must be going up or down, which way? Now look at the picture, tell me which way this is going to, if you put E down, what's going to happen? You see, it's not going to go like the other part. It's not going to go like that. Everybody understand that? It's going to go like this. Is that correct? Everybody see that? So what happened to the point B? The point B is going, the point C is going down. So this one is under, look what happened. Where the rod, where the rod is. This rod is here, and this rod is here. Yes or no? So if this is going to go up, this rod is under tension or compression? Tension. If this is going to down, this is under tension or compression? tension. Both of them, you don't see it that way, but both of them are under tension. Notice if this rod was underneath, it would have been under compression. Everybody understands this is going like this. So pivotal point is somewhere here. So all you have to do is this. Free body diagram again. This is 10,000 pounds or 10 kips. Is that correct or not? How do I write this in tension? Now I have said it 3-4 times. I don't want any more mistake. Should I put it down or should I put it up? Down, correct? Everybody we see, a few of you are not answering again. If I put this one in that direction, come on, I'm getting this out now. So let's put it this way. This is unknown. So if I'm putting it that one, which is FBA, I believe, yes or no, correct? That means this rod here gets this one. Therefore, it is under tension. You are right, okay? So how about the other force? Where should I put this force here? Up or down? Up, that's right. You see, many of you have got it. I'm glad. FCD. Again, that means this member is under tension. Is that understood? Yes? And then what happened there? You calculate delta AB. You calculate delta because we are running out of C. And this is going to end up like that. This is going to go up. This is going to go down. This is going to go like that. Is that correct or not? Yes? So the pivotal point becomes point O. Can I calculate that location? Yes. Again, similar. This is all about similar triangle. Because this length, let me give you the number. Just give me a couple of minutes so we finish. Because you have a homework like that, I'm a little bit concerned. So I'm going to tell you what does happen. This is going to be 0.00185 inches. This is going to be equal to 0.00307 inches. But when you have this length and that length there, you call this distance from here to here x, and the total length is equal to 10. Yes or no? Then you use similar triangle in this format. This delta AB is 0.00185 inches. Delta BC, using that formula, is equal to 0.00307 inches. Then you say x over 0.0185 is equal to, because this is x, this distance from here to here is 10 minus x, because it's 10 inches total. Yes or no? 10 minus x divided by this 0.00307. Then you calculate the location of the x, which ends up to be equal to 3.77 inches. As soon as you have this length equal to 3.77, then you use geometry to calculate how much that point going down. The rest, again, is geometry. Yes or no? Notice in the book, they end up with the angle. I do not like the angle. I always use the ratio, which is much better. Is that understood? Okay, good luck with your homework. If you have any question, please come out to the office hours. We have office hours now. And there will be all this subject that I covered here will be in your homework, will be your quiz. Is that understood? Yes, but I covered everything in your homework. Yes.